Hey guys, how's it going? In this video, I'm going to merge sort. So the famous team sort algorithm is actually based on merge sort and insertion sort. So team sort is actually being implemented in the Python language in 2002. So why there are so many sorting algorithms out there? Why merge sort is being used practically? It's because it's very stable and also very efficient. So the time complexity for the merge sort in the worst case scenario is big over n log n, and on also the same as the average case. So for a lot of sorting algorithm, the worst case scenario will be n squared, but merge sort is a lot more efficient. And merge sort takes a little bit of space to speak over n. By stability, and there is a formal definition from Wikipedia. As you can see, is teams merge sort sort equal elements in the same order that appear in the input. So this is important for a characteristics for a sorting algorithm. There is a very good animation from Wikipedia that illustrate how merge sort works. And also, I'm going to describe for you on a piece of paper on how. So let's say we have an array of 4, 1, 3, 6, and we have to split the array in halves. So the first splitting will be have the left hand side, the left half is 4 and 1, and the other half will be 3 and 6. And then we keep doing that until we reach that each one of the array contains only one number. So we keep splitting it until in this stage where each element is only in one single array. And then now we can start to merge them. At the same time, when we merge them, we compare the two number and sort them at the same time. So for example, 4 and 1, when we merge the two of them, the 1 is more than the 4, right? And then when we merge the two individual array to one single array, and the 1 will be before the 4. Same thing, 3 and 6. 3 is smaller than 6. So when we merge them, at the same time when we sort them, 3 will be before 6. And then now we have the two arrays. Each one of them has two elements. And then we merge them, at the same time we sort them as well. So when we merge them, we compare each of the elements when we look through them. So for example, the first element is 1, and then compare that against the first element of 3. 1 is smaller than 3, so the 1 will go to the first spot. And now the 3 will be compared against the 4. And 3 is smaller than 4, and 3 will be in the second spot. Okay, so and then the 4 will be used to compare against 6. And 6 and 4 is smaller than 6, so 4 will be in the third spot. And now what is left is only 6, so that is automatically in the last spot. So this is the basic algorithm of the merge sort. So now let's take a look at how can we implement on Python code. So merge sort requires two functions. One is called merge sort, another one is for merge. Basically, this is doing both the merging and the sorting. Okay, and let's walk through the first function first. I will share all this code in the description down below. So if the length of the list, the given list, is less than or equal to 1, that means it's either the list is empty or it has only one element in it. That means it's already sorted, right, by default. And now if there are more than one element in the list, we look at the middle index, where we will just take the length of the array and then subdivide it by 2, which we will return an integer. And we need the left half and the right half. Basically, we look at the index So on the original given array. And when we, so Python allows us to do this really easily by using indexing, right? So this one will, the left-hand side will be including the first element all the way to the middle index -1, and the right index will you started from the middle index all the way to the end, right? So we basically splitting or dividing the original given array to two halves. And now we can perform the merge sort on the left half, also on the right half, by recursively push back to the function, and then keep doing the dividing until one array contains only one element. So this is the terminal condition. And after that, we can do the merging. Okay, we merge the left half and the right half. So the first merge that will be called will be the left half has only one element and the right half has only one element as well. And then when we merge that, when we come back, we will be one array that contains two elements. So essentially, let me go back to the piece of paper that we wrote. So essentially, these lines of code, what they are doing is to keep. So it goes all the way from here, splitting, and all the way to this stage, right? Each of the array contains only one element. So this is what all these four lines does. And then now we started to merge. At the same time, you sort. Let's walk through this code, this function. We first need a sorted merged array, which is empty at the beginning. And now we need the i's and j index, who will be indexing the left half and the right half. So while there are elements in the left half, also elements, there are elements in the right half, and we do a comparison. So this is where we do the sorting, right? If the number that is on the left half or at the right in the I index is less than the j index that is the right half, and then we will pick the smaller element and then append it to the sorted and merged list. And after we look at the ith guy of the L array, and then we will increase the I index by 1. Same thing on the other hand, if the right, the j index at the right half is smaller, and then we will append that element to the sorted merged list. So essentially, we always pick the smaller guy when we choose between the left half and the right half, and then we traverse the left half and the right half until one of the two halves. We go through all the elements in one of the two halves, right? So that's why this end condition in the while loop. And now if there is something left on the left half that has not been dealt with, and then we collect all the number and then append it to the sorted and merged list. Same thing for the other half. If there's something left on the right half, we append the leftover to the sorted and merged list, which we will return at the end. And this is exactly how we do the sorting and the merging. Let's run that and sort it. As you can see, it takes a little bit space. Like for example, sorted merge. This is a some extra space that required by the function, and also, so what we can do is to optimize this space complexity to make it use less of space and to do everything in place. Okay, so this is a slightly space optimized solution. So now we don't need the sorted merged list, and so I commented out. I'm gonna walk through them with you. So the first step is to and now originally when the list is smaller, the length of the list is smaller than or equal to 1, we return the list, and now we don't return nothing, right? Just return the keyword. We don't have to return the rest. And then there's nothing returned from the merge sort now, and I comment it out and just we directly do it in place. We call the function on the left half and also call the same function on the right half and do the same thing in place. And then the merge side, originally we had a return, and now we do not have a return, but we have to have a container to contain the merge list. So what we can do is to do it on the given list that we pass into the function, and then we pass the same list to the merge function, where we will collect all the merged and sorted elements. So originally we appended the smaller number to the sorted merge list, and now we just point to the kth index of the given list to the smaller guy. So originally we have only I and j index. Now we have a kth index, which is for the given list that we collect the smaller number of the two arrays. And at the end, if there are any leftover, and then we will append it to the given list as well. So by doing this, we're doing everything in place, and so this is more optimized for the space. Let's run it, and we got the exact same solution. So this is my solution to the merge sort. I hope you enjoyed it, and I will see you next video. Thank you so much for watching.